Working 1 2 3. Okay, so welcome everyone. This is the first video in a different the different section of my channel. So this section is called Tech Talk, and basically this space is going to be used for programming and technology in general. Well, basically some of the topics that I have here. So it will be some programming tutorials, some software architecture kind of designs and tutorials as well. We will be trying some SaaS services or cloud services in general, and we'll be focusing on open source as well. So this new section, it will be mostly around more of the nitty and the gritty about programming and software engineering in general. The difference between this one and the one that I have in Spanish about how to not build software is that this is going to be, first thing is going to be in English. So the idea of these videos is that it would be possible to reach more people than the ones that I have in Spanish. And also, as we're going to focus on more like the technical spaces and the coding, programming, development of applications. So in the other one, it would be more like everything that is outside of it. But in this one, we'll be kind of getting deep into that. So yeah, that's kind of the introduction of this. And today we're going to be talking about Next.js Open Telemetry Instrumentation. So this is going to be a free video series where we're going to be discussing section by section, step by step, how you can instrument a Next.js application with Open Telemetry. So and this one is basically just going through the initial concepts and setup, but it's not going to be kind of focus on the actual code, at least for today. We'll have those other sessions in the following videos, and today I'm just going to focus on explaining things, how this works, what is Next.js, what is Open Telemetry, and why it's important. So to start with the topic, I would like to focus on the problem that it's trying to solve. So what's the problem? So if you have worked in enterprise level applications, or you have worked with distributed systems means that you have like microservices or different or distributed systems is like microservices that can be done with serverless or Kubernetes or any of those new technologies that exist today, to have basically split the work that you will have in a monolith system into smaller pieces. And what happens is that sometimes when a bug happens on this type of scenarios, it can be really hard to understand what is going on, where the problem is, and kind of fix the issue. So I have an analogy here where I'm just setting a picture of Mario. So usually what happens is that when you have multiple levels for your system, let's say you have a front-end application that is built, I don't know, in React or Angular, and then you have a backend system that probably is an aggregation layer that is connecting to different backend services for user information or for payments, that kind of stuff. And also you can have other type of requests to outside APIs, let's say for Strapi for payments, or I don't know, whatever thing, the iteration that you might have. Debugging and finding the issue within these different layers can be really difficult. Sometimes what the QA person or the user sees is just pressing a button, and after pressing a button something is not working correctly, instead of trying to understand what is going on behind the system, because that will be really difficult for probably a front-end QA person or the user, right? So users will usually just communicate with customer service or somewhere like that, say, hey, I press this button and the app is not working, right? So and that becomes a bug, a ticket in the for the engineering team, and you have to find what is going on within the system. So usually when we are trying to debug this type of problems, we have methods for having logs or distributed logs. In this case, you can have, I'm going to talk about my experience. So having worked on a serverless application, you have the CloudWatch logs where you can see everything that is happening for each microservice and each of the requests. And that can introduce different problems if you don't have a standardized way for logins, for logging. So one of them is, what if you're not logging enough information to identify what the problem is, or you don't have probably one of the services doesn't have the login enabled, or you are dealing with a lot of sensitive data that you don't want to log, so it's not like quite acceptable to have those type of information showing in the console, the logs. So there's a lot of issues that you can find with logs. And also what ends up happening is that you start from the front end. The front end has a set of logs. You can identify a couple of things, probably the events for the click or the user, that kind of stuff, and then you find that there's nothing that happened within the front end. So you go to the next layer, right? And the next layer is the aggregation layer for the API, and you can get the same issues, not a standardized way of logging, or possibly there's not a problem on that specific layer, so you need to go to the next one. That could be a backend service that has the user information or the payments, that kind of stuff. And so you go basically castle by castle, like Mario, trying to find where the problem is, where the princess is. And sometimes you take a lot of time just to find something that can be caused on any of the layers, from all the way to the client side, the front end, to the very bottom of the tree. They could be a backend service or a scheduler or whatever that is happening over there, or an interaction with another API, external API. So what happens is it becomes really hard to track, and during important things like deployment, you find an issue that you need to fix right away for the deployment. It can be really hard to find the solution. So that's kind of the problem that I see with this type of non-standardized or ways of logging. So for that we have something called OpenTelemetry. So OpenTelemetry is a collection of tools. I just grabbed this information from the OpenTelemetry website. So it's a collection of tools. It has some API SDKs to instrument your application. So OpenTelemetry is basically, it can also be described as a standard. So it has a bunch of rules and presets on how you want to communicate your different services in a distributed system, and how you want to kind of provide the logging information or the tracing information across these different systems. So let's say in the case where I was describing the previous problem, what you can do is having all of the services, all of the layers connected within each other, and a single request can go from the front end all the way to the request for the database to do the insert query or the get select query. And you can see everything within the system, every operation, every different step along the way for that specific request. And there's specific data stores and trace stores that you can see all of the different information in live that is happening within the system. So in this case, instead of trying to go layer by layer, you have a trace for the specific request, and by you can attach a request ID that goes from the front end or something like that, And by getting that trace, you can just analyze what happened on each of the steps without having to go to a specific centralized logging or the different CloudWatch entries that it might have. And also, you don't have to kind of have access to any of the other systems, because these data stores for the traces have basically everything that you need. So this is basically this is what OpenTelemetry is. It's just a set of tools, APIs, and SDKs, and it helps you to instrument, to collect data, and export it. As I said, it works pretty good. Or the idea is that it helps with distributed systems. Now, another thing is that it supports multiple languages. So what you can do is that actually there's a demo that it has different backend services, and each of the microservice is written in a different language. So you have like PHP, you have Go, you have Node, you have C++, and this is only the way that is used to showcase how you can instrument every different language that is exists. I mean, probably there's some weird ones that doesn't make sense to have this type of instrumentation, but at least for the basic ones that most of the developers use in daily basis, you can have something like that. So you have support for multiple languages, and also it has support for the most common operations. So we have our transactions. In this case, most common transactions between distributed system could be an HTTP request or a gRPC request, or things like, okay, a database query using a specific connector like MongoDB or Postgres, and also things to for frontend, you can also capture things like clicking events or fetch from the window object. And one other thing is that 100% free to use and open source. So OpenTelemetry is basically available for everyone and every team to use. And the idea is that more and more vendors like Datadog or OpenTracing, those type of vendors start to accommodate these standards or these tools on the collector to their platforms. So this becomes like the global open source way of dealing with tracing, instead of just having each vendor with its own proprietary way of dealing with that. Okay, so we can go to next slide. Okay, so how does now getting a little bit deeper into what OpenTelemetry is and how it works. OpenTelemetry is divided by it has a set of signals or set of entities or concepts that compose a trace, and some of them are described here, or the more like relevant ones for when you are starting to use OpenTelemetry. Or this, I can say that this could be the four ones. So trace, OpenTelemetry main element is traces. So you can say trace is it's like the whole transaction that happened within the system. So you can take as it says here, is just a picture of what happened from the initial request from the user on the client side or the mobile application, whatever, all the way to the very bottom of the tree. That could be a database request, something like that. So a trace is the encapsulation of a single transaction or single request that goes from the start to the very end. The span, so traces are composed by spans. So each of the span could be captured as a operation within the system. So you can say that the front-end request might have two spans. The first one is the click event for the user checking the order for a web store, and the second span would be the fetch request that happened to the API. So you can have the API request with all of the details that were triggered by that request. So that those are two spans, and then the following spans can start from the API side. So you can say, okay, the first API span could be where it receives the request, the incoming HTTP request. The following one could be something like validating the request from the client. and then you can have like setting information to the database or validating the user authentication. And also the next spans could be something like, okay, triggering the secondary request or a message to the queue for a worker to process, I don't know, the email that is sent to the user or the shipments details, that kind of stuff. So that's kind of a span. It's a operation within a trace. And as he says here, spans are the building blocks for traces. And then the third concept is a trace context. So trace context, I can see it as the glue that puts everything together, all of the spans together. So let's say that you have, how would you say that, how can you translate the span information or related span information that goes from one service to the other? This is done by the trace context, and the trace context have different standards and ways to pass the information from one service to the other, or how you create a span with a different context depending on of the operation. So in this case, let's say that going back to the web store example, the frontend does the click event, that is the initial span, and doesn't have any context because that's the kind of the first span. And then the second span is the fetch request, which will be carrying over the context from the first span, so it becomes a children over the first span. And then the fetch request, based on the trace context implementation or the context propagation that is called for OpenTelemetry, triggers sends specific information to the API service to say, okay, the first span or the next spans that are created within the service need to have the same context as the ones on the front end. So you can continue kind of that different sequence of spans that are chained together to become the final trace. And this is represented by a non-cycling chart, a tree, where you can have a specific span can only have a parent span, and it cannot be kind of a loop or something like that. And a span can have multiple children. Okay, the last thing is baggage. So baggage is extra information that can be sent from one span to the other or from one system to the other. Let's say that I want not only to send the trace context from one service to the other, but also want to send information about the user or information about the purchase or about, information for anything. This baggage implementation or concept helps us attach more information than what is required for the trace context. Okay, now that we have gone through the kind of specific concepts of OpenTelemetry, what OpenTelemetry is, we can continue with Next. So what's Next.js? Next.js is a React framework. As it says from the Next.js website, it says that it gives you the best developer experience while the features you need for production. You have things like hybrid static and server rendering, TypeScript support, smart building, route prefetching, and more. It says that you don't need any config. So basically, Next.js is a hybrid framework for React applications that can execute code from the node side, that is the server side, and the client side, that is the browser side. And this is done by different techniques that you can use. You can run things like static websites for static kind of pages for things like product details pages or things like that. And also you can have more complexity around the browser side or the client side, and leave the backend or the server side just to print the basic HTML. So there's many ways that you can approach creating an Next.js application, but the most common one is just, okay, I'm going to build a couple of pages that have some React code, and probably there will be a couple of requests from the front end, from the client side or browser side, and also I need to build a couple of API routes for my Node.js side on Next. So so previously I built a Pokemon API that had a create React application that were both instrumented, and also I work with the Open Telemetry kind of team to work on the demo application where they have I worked on the Next.js application and instrumented the whole thing from the backend and the frontend. And I didn't find much information on how to approach this because Next.js is a kind of weird hybrid where most of the tools that are for OpenTelemetry just tell you, okay, this is how you instrument the Node.js application, or how this is the way that you instrument a client-side front JavaScript application. But it doesn't talk about the specific scenario where you have, or you can have the same two scenarios, the same two ways of instrumenting an app in the same framework, on the same place. Just a couple of just a quick thing about Next. What makes Next work using server-side rendering is that it has a feature called code hydration, and I think this is part of some of the React implementations where once the code is the HTML is rendered by the server and pushed to the client side, there's a hydration process from the client side code that will convert that code into actual it will execute that code and rehydrate the state and other things. So that's kind of how Next.js handles the server-side rendering. First kind of print and the following execution of the React code in the client side. Okay. Now that we have gone through the basics of Next, let's go and talk about. Actually, I think I already talked about this, but let's just go more in depth. So I found this image in the web, and it has I think a better explanation about this concept of server side versus browser side. So in the context of a Next.js application, as you can see, the file server is at the same in the same line of the API server. So this is a sequence diagram, right? Where the file server is pretty much in the same line. So this means this is Next.js being the two of them, because it becomes it's just a node application that serves as an API and also the file server. So when the browser requests a specific page, the file Next.js renders the first version of that page on the server side. That's why it's server-side rendering. And then it pushes the HTML to the browser on this section. Then the browser runs the hydration process on that end, and then it starts running the React code on the front end, on the browser client. So, and then the following requests, the fetch data request, the API request, go from the browser side to the specific API endpoints that you describe on using Next. So that's kind of where you need to instrument both the Next.js application backend side and also the client side. And that's where it gets tricky, because you have to support the instrumentation for both sides. And some of the things that you need to consider is that you can find node-specific SDK tools for OpenTelemetry, JavaScript browser client tools, but also you need to consider that the hotel collector or the collector for OpenTelemetry should be accessible for not only the backend, or in this case if you see Docker Compose or something like that, not only the internal Docker network, but also from the front-end side where is the browser, and the browser requires different steps to reach that service. One of them is the CORS, so you need to be careful around CORS, and also around the how you configure the hotel collector to like exposing the specific ports and that kind of stuff. Okay, so I guess that's kind of the last thing I have for today. This is just kind of going through the concepts and how you can start thinking about how to instrument a Next.js application. This is just to have the base work kind of explained, and then the following videos will go through the rest of the details. That is, how do I instrument the backend, how do I instrument the frontend, and how you can start looking at the traces in Jaeger. How can I have my Docker Compose set up so I can just run Docker Compose up and have everything running without having to install all of the services locally. So yeah, so this is kind of the first thing. I'm going to leave you the repository that I'm putting together for this demo, for these videos. This is called Next.js Hotel Instrumentation. It's on my profile, GitHub profile. And also, if you have any questions for me, you can reach me on Twitter at @orreyes _IO. So yeah, I guess that's it. I see that I have a question in the chat from Javier. Is Next.js more scalable than Express? It depends. I would say if you use things like a CDN and a static website for Next.js or a serverless, it can be possibly more scalable than what you have on Express, because Express is just a server-side support, and it doesn't have serverless implementation unless you just put it. I mean, it's not meant for serverless, but you can have it. You can use it as with microservices and Kubernetes, but Kubernetes, it has a different way of dealing with containers and microservices than what serverless would do. So is it more scalable? Well, I guess it depends on what you're using, how you're using it. I would prefer Next.js at this point, because Next.js just brings more features from the get-go. It has TypeScript support out of the box, as well as React server-side rendering and all of those different tools. And Express is just mainly for just creating your routes and serving the data to the clients and that kind of stuff. It doesn't have that many tools or features out of the box. Okay, so I think that's the last thing that I want to touch on. Thank you for watching, and see you in the next video. Bye.